Hello friends, welcome to my channel Eccentric Learning. Many videos on various quantitative aptitude topics like time speed distance, quadratic equation, maxima minima, etc. has already been uploaded. I hope you guys are going through that. If not, some of the videos link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. Today, we are going to start a new topic, polynomial, in which we will be seeing what is a polynomial, how to factorize a polynomial to find its factors, what is a factor or remainder theorem, and so on. So let us start with today's video. Let us first see what is a polynomial. The word polynomial consists of two words, poly and nomial, which in Greeks means many and nomial means names. Mathematically, this simply means that any algebraic expression which contain many terms and are consist of constant and variables, and the variables are raised to a non-negative integral power, then it can be termed as a polynomial. For example, 6x raised to power 5 plus 4x raised to power 3 plus 2x plus 7. So this is an algebraic expression which consists of constants and variables, and the variable is raised to a non-negative integral power. So this can be termed as a polynomial. In a similar way, if I consider this algebraic expression, say 3x plus 4. So this can also be termed as a polynomial as it contains constants and variables, and the variable is raised to a non-negative integral power. So any algebraic expression which consists of constants and variables and the variable is raised to a non-negative integral power can be termed as a polynomial. Now, we often hear the words monomial, binomial, trinomial, and so on. So this simply means that any polynomial which consists of only one term is called as a monomial. In a similar way, any polynomial which consists of only two terms can be termed as a binomial. In a similar way, any polynomial which consists of three terms can be termed as a trinomial, and so on. So one example of monomial can be simply 6y, where I have considered the variable to be y. In a similar way, one example of binomial can be 3x plus 4 as it contains only two terms. In a similar way, one example of trinomial we can take to be 6x cubed plus 2x plus 8. So this polynomial consists of three terms, so this can be termed as a trinomial. We also often hear the word degree. So degree of a polynomial simply means the highest power of the variable in a polynomial. For example, if I consider this polynomial, so here the variable is x and the highest power of this variable is 5. So this can be termed as a 5-degree polynomial. In a similar way, if I consider this polynomial 3x plus 4, in this, the highest power of the variable is 1. So this is a 1-degree polynomial. 1-degree polynomial is termed as a linear polynomial. So 3x plus 4 can be termed as a linear polynomial. In a similar way, when the highest power of the variable in a polynomial is 2, then it is termed as a quadratic polynomial. For example, 4x squared plus 2x plus 7. So here, the highest power of the variable is 2, so this can be termed as a quadratic polynomial. In a similar way, if the highest power of a variable in a polynomial is 3, then it is termed as a cubic polynomial. For example, 4x cubed plus 3x squared plus 8. So here, the highest power of the variable is 3, so this can be termed as a cubic polynomial, and so on. Now suppose if I have this algebraic expression 4x raised to power minus 7 plus 2x cubed plus 7x plus 6. So can this algebraic expression be defined as a polynomial? Since the power of the variable is a negative number, so this algebraic expression cannot be defined as a polynomial. So a polynomial is a mathematical expression which contains many terms and consists of constant and variables, and the variables are raised to some non-negative integral powers. Also, a polynomial can be written as p of x, that is a function of x, since in this case the only variable is x. In a similar way, instead of x, if the variable would have been a, in that case the polynomial could have been written as p of a. So here the variable is y, so this can be written as p of y, and so on. Now, let us see how we can factorize a polynomial. Let us consider a quadratic polynomial as x square plus 5x plus 6. So, when we factorize this quadratic polynomial, the two factors would be simply x plus 2 and x plus 3. Well, the factorization of a quadratic polynomial we have already covered in the quadratic equation videos. So in case if you are facing difficulty how to factorize this quadratic polynomial, I would request you to go through those videos first and then to come back to this video. Since x plus 2 and x plus 3 are the factors of this quadratic polynomial, so at x equal to minus 2 and at x equal to minus 3, this quadratic polynomial will attain a value of 0. So we can say that x equal to minus 2 and x equal to minus 3 are the two roots for this quadratic polynomial. Now let us consider this cubic polynomial and let us try to find the factors or the roots of this cubic polynomial. To find the factors or the roots of a polynomial of degree more than 2, we need to go for hit and trial first. By doing hit and trial, we need to find the first factor and then we can find the remaining factors. So to find the first factor, we need to put some random values of x for which this expression will be equal to 0. So by putting some random values of x, we can see that at x equal to 1, this polynomial attains a value of 0. So we can say that x minus 1 would be a factor for this cubic polynomial. So this px can be written as x minus 1 times some quadratic polynomial here, as when this linear polynomial x minus 1 would be multiplied by a quadratic polynomial, in that case we can get a cubic polynomial. So now we need to find this quadratic polynomial, which we can find simply by dividing this cubic polynomial by this factor x minus 1. So now let us divide this cubic polynomial x cube plus 2x square minus x minus 2 by this factor x minus 1. So here we have x cube and here we have x. So we need to multiply this factor by x square. So in that case, this would be x cube minus x square. So if we subtract this, then this would be minus and this would be plus. So we can cancel this x cube and x cube. So this would be 2x square plus x square. So 3x square, and this would be minus x and minus 2. Now here the power of x is 2 and the coefficient is 3. And here the power of x is 1 and the coefficient is 1. So we need to multiply it with 3x. So in that case, this would be 3x square minus 3x. So again, if we subtract this, this would be minus and this would be plus. So we can cancel this too. So minus x plus 3x. So this will give us 2x and this is minus 2. So 2x minus 2 and we have here x minus 1. So if we multiply this x minus 1 by 2, so in that case, this would be 2x minus 2. And if we subtract this, there won't be any remainder. So this would be 0. So when we divide this cubic polynomial by this factor x minus 1, the quotient would be x square plus 3x plus 2. So this cubic polynomial can be written as x minus 1 times of x square plus 3x plus 2. Now again, this is a quadratic polynomial which we can factorize further. So after factorizing this quadratic polynomial, the other two factors would be simply x plus 1 and x plus 2. So the three factors for this cubic polynomial px would be simply x minus 1, x plus 1 and x plus 2. So in this way, we can find the factors of a polynomial of degree more than 2. Now, since x minus 1, x plus 1, and x plus 2 are the three factors of this cubic polynomial, so we can say that this cubic polynomial will attain a value of 0 at x equal to 1, at x equal to minus 1, and at x equal to minus 2. So x equal to 1, x equal to minus 1, and x equal to minus 2 are the three roots for this cubic polynomial. So we can generalize this and we can say that x minus a is a factor of the polynomial px if and only if a is a root of the polynomial px. That is, at x equal to a, the polynomial will attain a value of 0. That is, p of a would be 0. And this is called as remainder or factor theorem. This theorem is a very useful one as we can solve many questions directly simply by using this theorem. So now let us see some questions based on this theorem. Let us see this question. Is 3x minus 1 a factor of this quadratic polynomial? Well, one thing that we can do is we can simply factorize this quadratic polynomial and we can see whether 3x minus 1 is a factor or not. Or what we can do is we can simply use the remainder theorem. So if 3x minus 1 is a factor of this quadratic polynomial, in that case, x minus 1 by 3 will also be a factor of this quadratic polynomial. So using the remainder theorem, if x minus 1 by 3 is a factor of this quadratic polynomial, in that case, x equal to 1 by 3 should satisfy this quadratic polynomial. So if we assume this quadratic polynomial to be px, so in that case, p of 1 by 3 would be simply 3 into 1 by 3 whole square plus 5 into 1 by 3 minus 2. So this would be 3 into 1 by 9. So that would be 1 by 3 plus 5 by 3 minus 2. So 1 by 3 plus 5 by 3 would be 6 by 3, which would be 2, and there is minus 2. So this is 0. So P of 1 by 3 is equal to 0. So that means x equal to 1 by 3 is a root of this quadratic polynomial, or x minus 1 by 3 or 3x minus 1 is a factor of this quadratic polynomial. So we can solve such questions directly simply by using the remainder theorem. Let us see this question now. Find the remainder when the polynomial px x cube minus 7x minus 6 is divided by the following. The first is x plus 2 and the second is x minus 1. Well, one thing that we can do is simply we can divide this polynomial px by these factors x plus 2 and x minus 1, and we can simply find the remainder. But that would be too much time consuming. So let us see one easier way of finding the remainder in such cases. Well, to use that, let us first try to understand a very small but important concept. Suppose if I have a polynomial px as x square plus 5x plus 6. So the two factors for this quadratic polynomial would be simply x plus 2, x plus 3. So now if I ask the question, what is the remainder when this polynomial is divided by x plus 2 or x plus 3? The answer would be simply 0, since x plus 2 and x plus 3 are the two factors for this quadratic polynomial. But suppose instead of px equal to x square plus 5x plus 6, if I would have given px as x square plus 5x plus 7. In that case, this can be written as x plus 2, x plus 3 plus 1. So now when this polynomial is divided by x plus 2 or x plus 3, the remainder would be simply 1. But every time we don't have to write the polynomial in this way. What we can do is we can simply take the polynomial in this form and we can directly put the value of x to be minus 2 or x to be minus 3 to find the remainder. For example, when we put x equal to minus 2 in this polynomial, in that case, p of minus 2 would be simply minus 2 square plus 5 into minus 2 plus 7. Now, when you simplify this out, you'd be getting the value of p of minus 2 as 1. So the remainder would be simply 1. In a similar way, when we put x equal to -3, p of -3 will also give us the value as 1. So when the polynomial px, x square plus 5x plus 7 is divided by x plus 2 or x plus 3, the remainder would be simply 1. Now we can apply the same logic to this polynomial. So we need to find the remainder when this polynomial is divided by the following x plus 2 and x minus 1. So to find the remainder, what we can simply do is we can put p of -2 for the first one and p of 1 for the second one. So p of -2 would be simply -2 whole cube minus 7 into -2 minus 6. And when you simplify this out, this would be simply 0. In a similar way, p of 1 would be simply 1 cube minus 7 minus 6. So this would be minus 12. So the polynomial px when divided by x plus 2, the remainder is 0, so which indicates that x plus 2 is a factor of this polynomial, and the remainder when this polynomial is divided by x minus 1 is simply minus 12. So to solve such kind of questions, we can directly put the values and can find the remainders. Well, indirectly if you see, we are using the remainder theorem here, which states that x minus a is a factor of a polynomial px if p of a is 0. So that means there is no remainder. As in the first case, when this polynomial px is divided by this factor x plus 2, in that case, p of -2 is 0. So that means there is no remainder. So x plus 2 is a factor of this polynomial px. But in the second case, when we put x to be 1, in that case, p of 1 is -12, which is a non-zero number. So x minus 1 is not a factor of this polynomial px, and the remainder is -12. So a remainder theorem can also be thought in this way, that if a polynomial px is divided by x minus a, then the remainder would be given by p of a, and if this p of a is 0, then only x minus a would be a factor of this polynomial px. So for such kind of cases where we need to find the remainders, we can directly use the remainder theorem. So that's it for today's video, in which we have seen what is a polynomial, how we can factorize a polynomial, what is a factor or remainder theorem, and we have also seen some questions based on this theorem. But I would request you to practice some more questions, because the more you practice, the more you learn. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.